Welcome to the wide world of construction blasting, a look at innovative techniques and methods. This presentation today is brought to you by the University of Alabama civil engineering students Will Bertrand, Kenneth Stallworth, and Tyler Murphy. From coal mining to land development, every contractor or company longs to utilize efficient excavation techniques. Land excavation is a term indicating the removal of soil or earth material from the ground. When large rock formations, however, cause large pieces of machinery to struggle, blasting continuously is used as an economical method to remove rock. Rock blasting, by definition, is the controlled process of using explosives and other techniques in order to excavate, break down, or fragmentize rock for easy removal. While originally thought to be used as early as the 10th century by the Chinese, it wasn't until a formula for black powder was developed by the English friar Roger Bacon that it was considered a blasting agent. Blasting is utilized daily in the civil engineering world as one of the most effective tools for excavation. Blasting is broken into two types of energy, which is released, causing rock fragmentation: shock waves, which cause combustive energy, and high gas pressures. The three main types of explosive used in the industry today are dynamite, amphos, and slurries. The best way to explain the blasting process is through the concept of rock fragmentation. The overall goal of this document is to discuss and report the application of innovative technical advancements and corresponding methods of study in relation to blasting. Areas of study include controlled blasting methods, as well as the advanced control and reduction techniques associated with vibrations utilized in the construction processes.
Today we're going to discuss controlled blasting, which minimizes the overbreak of fractured material beyond the desired boundaries, and vibration control, which reduces the amount of vibration from the blast to the surroundings. The two most common blasting control techniques are line drilling and pre-splitting. In line drilling, a single row of closely spaced, unloaded, small diameter holes are drilled along the excavation line. In pre-splitting, desired control patterns are achieved by firing a single line of holes before the initiation of the rest of the holes in the pattern. Each method holds one main objective in common: to reduce and better distribute the force of the charge and minimize the fracturing of the rock beyond the excavation line. Blasting water-filled concrete structures is a prime example of controlled blasting. In construction and mining work, situations occur where hard rock or concrete are needed to be excavated at sites near critical structures or utilities. Due to the concerns of damage caused from blasting, contractors and engineers have to decide what methods are to be used to provide the safest environment, but also be economical and practical. In past projects, entire structures were brought to the ground because of the failure of one or more members or substructures. Methods such as blasting water-filled concrete structures eliminate this problem.
One of the most pressing and pertinent concerns associated with blasting of any type is the control and mitigation of blast-related vibration. Vibration due to blasting raises many issues for a variety of parties. If left unchecked, it can contribute to unsafe conditions for workers on site, as well as cause major problems for nearby structures and discomfort and disruption for residents of the surrounding areas. One key way to better control blasting vibration and its impacts is to have better technology to measure, record, and predict the actual vibration produced by a proposed blast. A company called Orica Mining Services uses technology called Advanced Vibration Management. This technology takes information from controlled blasts to create computer models of proposed blasts and to create new and better scenarios to improve the blast. This information creates more controlled and safe blasting areas and reduces the probability of on- and off-site accidents. Innovation is not always inventing brand new technologies to solve a problem. Sometimes it is finding new creative ways to utilize and combine existing technology. Part of the appeal of this method of innovation is the ability to have extreme customization from site to site. Also, you do not have to actually fabricate new systems or use extra money on groundbreaking research. Blasters also have the experience in each existing area to know the risks involved in using these techniques. It is important as we move forward with new technologies to be sure to address the risks associated with blasting, especially as we move closer to more populated areas. Some of these concerns involve structures and utilities, environmental and water resources issues.
In some cases, owners and engineers simply avoid the risk of blasting by specifying that only mechanical methods are used for excavating rock, usually increasing the cost of the project. Sometimes mechanical-only methods cannot complete the project and blasting is ultimately used. The skill of the people involved in the work is often the key factor that allows blasting to become a feasible option. The main benefit of any type of blasting operation is safety. Safe and thoroughly designed blasting procedures will outweigh most, if not all, extra costs associated with the safety factor. These techniques discussed are able to control the vibration in blasting in confined areas and decrease the overall time and schedule of larger scale construction projects, and in turn reducing costs and increasing the benefits. Blasting will always have strict regulations that engineers must work around, and implementing techniques that will maximize the use of the explosives while remaining compliant to these regulations is advancement from past blasting practices. These techniques will need to be further innovated in the future as blasting will become more and more regulated.
At some large civil construction projects, blasting is often only a small part of the overall work. Blasting engineers and contractors utilize technical innovations that have developed throughout time in order to complete the task at hand efficiently and safely. By strategically running a construction process, innovative technical advancements similar to those explored in this document have helped individuals and companies to continuously evolve the blasting process into what it is today.